right, in example one, we are going to look at the wheel used on Wheel of Fortune. So here's an example of one of the wheels that may have been used in a show. It says the wheel on Wheel of Fortune has 24 equally sized spaces. What is the probability that a contestant spins the wheel and lands on an orange space, the $20,000 gold space, bankrupt or lose a turn, and then finally a brown space? All right, so there's a picture of a sample wheel. And again, we're told we don't have to count all the spaces. We're told that there are 24 equally sized spaces, okay? The equally sized part is very important because all the spaces are the same size. That means when a contestant spins the wheel, it's equally likely that the contestant will land on any of the 24 given spaces. Okay, so that's what we mean by equally likely outcomes. Because all these spaces are the same size, when you spin the wheel, it's equal possibility to land on any of the 24 size or any of the 24 spaces. Okay. All right, so here we go. Let's start with the probability of spinning the wheel and landing on an orange space. Okay, so remember, all you have to do is do what we were saying earlier. Okay, go back to the basic probability principle. You're going to figure out, you're going to have a fraction for your probability. The numerator is going to be the total number of outcomes in the particular event that you're interested in. And you're going to divide by the total number of possible outcomes. Okay, so when you look at this, okay, the probability of landing on an orange, okay, there's 24 possibilities for landing when you spin the wheel. Okay, you can land on any of the 24 spaces. Okay, so that's the total number of possible outcomes when spinning the wheel. Okay, so the numerator is going to be how many meet our criteria. How many of these spaces are orange? Okay, so if I look at this wheel, I see an orange space right here, and I see an orange space right here. So 2 of those spaces are what I'm looking for. I want an orange space. Okay, so there's your probability, 2 out of 24. Okay, so you can reduce this. I mean, this is fine. This is a correct answer. If you want to reduce this fraction to be 1 over 12, that is fine. Okay, so if you wanted to compute this as a decimal, you could go to your calculator and you could do 1 divided by 12 or 2 divided by 24. And you're going to get this decimal. And notice it's one of those nasty decimals that goes on forever. This one, at least it repeats. So if you wanted to write it down as a decimal, I would put 0.083 with the bar on top of the 3. That just indicates that the 3 goes on forever. So if you wanted to, I mean, I prefer fractions, but if you wanted to give it to me as a decimal, that's fine, as long as you say that 3 repeats forever. Okay. Looking at the decimal version does help you confirm that your probability number is between 0 and 1. Okay, so that's a good thing. All right, so there's your probability for landing on an orange space. Okay, next, let's figure out the probability of landing on that $20,000 gold space, which is right here. Okay, so looking at the wheel, that's rare. There's only one of those guys. Okay, so there's 24 possibilities. That's what's going to go in the denominator always, the total number of possibilities. And there's only one spot that's gold and $20,000. Okay, so there's one spot out of 24, and that's your probability, 1 out of 24. All right, next, spinning the wheel. What is the probability of landing on bankrupt or lose a turn? Okay, you've got to watch the language here. Okay, so we've got or there, and it's underlined to make sure you pay attention to that word. Remember, or is associated with union. Okay, I keep reminding you, union is or, intersection is and. Okay, so if we're talking or, we're talking about a union. Okay, so remember, it's one or both. I mean, it can't be both. You can't land on both bankrupt and lose a turn. But because it's or, it's saying what's the possibility of landing on one or the other. Okay, so here it would be acceptable to land on bankrupt. Okay, and notice there's 2 bankrupt spots on the wheel. it's also acceptable for this event to land on lose a turn, which is right here. So there's 1 lose a turn, 2 bankrupts. So that means 3 spaces fit this criteria, okay? So again, you're going to take the 3 spaces, that's how many meet the criteria for this event. You're going to divide by the total number of possible outcomes, which is 24 spaces on the wheel, okay? So there's your probability. If you'd like, you can reduce this to 1/8, okay? You can even, like I said, convert it to a decimal. That should be 0.125, and that's the entire decimal, okay? So any of those are acceptable answers, okay? All right, finally, let's look at part D. What's the probability of landing on a brown space, okay? So when I look at this wheel, I see lots of different colors, but I don't see brown. Okay, so remember, this one is orange, this one is gold, okay, but there isn't any brown, okay? So 0 spots meet that criteria, okay? Out of the 24 total, 0 divided by 24 is 0, okay? This is an example of an event that cannot occur. There is no brown spot on the wheel, so it's not possible for the contestant to spin the wheel and land on a brown space, okay? So this event has probability 0, okay? So this was a nice little simple example just to get you introduced to probability, okay? You're just gonna, to form probability, it's gonna be a fraction. The numerator is going to be the total number of possible ways your event can occur, and the denominator is gonna be the total number of possible outcomes in general.